Hey everyone, and welcome to FACTENOVA, your new home for the most mind-blowing facts about our universe and the planet we call home. Throughout human history, we've looked up at the stars and wondered about our place in the cosmos. What secrets does the universe hold? What mysteries are hiding in the vast expanse of space? Here at FACTENOVA, we'll delve deep into the most intriguing and awe-inspiring facts about our planet and the universe, exploring everything from the age of the cosmos to the mysteries of black holes. So buckle up, get ready to expand your knowledge, and join us on this incredible journey of discovery. Have you ever looked up at the night sky and wondered just how old those twinkling points of light are? How long has the universe itself been around? Well, astronomers have been grappling with this question for centuries, and the answer is truly mind-boggling. Imagine a clock that's been ticking for almost 14 billion years. That's right, the estimated age of the universe is a staggering 13.8 billion years old. To put that into perspective, if the entire history of the universe were compressed into a single year, our solar system wouldn't form until late August, and humans wouldn't appear until the last few seconds of December 31st. But how do we even begin to fathom such an immense timescale? How do scientists determine the age of something as vast and ancient as the universe itself? It's like trying to determine the age of a tree after all the rings have faded away. Well, one of the key methods involves measuring the distances to distant galaxies and the speed at which they're moving away from us. This expansion of the universe provides crucial clues about its age. By observing the redshift of light from distant galaxies, astronomers can calculate how fast they're receding from us. Imagine the universe like a giant loaf of raisin bread baking in the oven. As the bread rises, the raisins within it move farther apart from each other. Similarly, as the universe expands, the galaxies within it move away from one another. By analyzing the relationship between distance and redshift, astronomers can estimate the Hubble constant, a measure of the universe's expansion rate, and by working backward from the current expansion rate, they can estimate when the universe began from a single point, marking the beginning of time as we know it. We all know that Earth is often called the blue planet, and for good reason. Roughly 71% of its surface is covered in shimmering, life-giving water. But have you ever stopped to think about just how much water that actually is and where it all comes from? It's easy to take water for granted, but this precious liquid is essential to all known life and plays a vital role in shaping our planet's climate, weather patterns, and even its geology. But here's the surprising thing. While oceans dominate Earth's surface, they only account for about 96.5% of all the water on our planet. The remaining 3.5% is freshwater, a tiny fraction in comparison, yet it plays an outsized role in supporting life on land. This freshwater is locked away in glaciers, ice caps, groundwater, lakes, rivers, and even the atmosphere. Think of it this way: if all the Earth's water were contained in a 26-gallon bucket, the fresh water available for our use would amount to less than a single gallon. That's a sobering thought, highlighting just how precious and finite this resource truly is. But Earth's water cycle is a continuous process of evaporation, condensation, and precipitation, constantly replenishing this vital resource. Water evaporates from oceans and other bodies of water, forming clouds that eventually release their precious cargo as rain or snow, replenishing rivers, lakes, and aquifers. This constant cycling of water is essential for life as we know it, but it's also incredibly vulnerable to disruption from human activities like pollution and climate change. So the next time you take a sip of water, remember that you're not just quenching your thirst, you're tapping into a vast and interconnected system that sustains life on our planet. Chapter 3: Black Holes, Cosmic Abyss. Black holes. Just the name itself conjures up images of cosmic monsters lurking in the depths of space, devouring everything in their path. But what are these enigmatic objects, and are they really as terrifying as they sound? In essence, a black hole is a region of space-time where gravity is so strong that nothing, not even light, can escape its grasp. Imagine a star many times more massive than our sun collapsing in on itself under its own gravity. As the core collapses, its density and gravitational pull increase to unimaginable levels, creating a singularity, a point of infinite density at the heart of the black hole. Surrounding this singularity is the event horizon, the point of no return. Once anything crosses this boundary, it's destined to be swallowed up by the black hole's immense gravity. But here's the thing. Black holes aren't cosmic vacuum cleaners roaming the universe, randomly sucking up everything in sight. In fact, if our sun were to suddenly collapse into a black hole, don't worry, it's not going to happen, Earth would continue orbiting as if nothing had changed. Of course, we wouldn't be basking in the sun's warmth anymore, but the point is that black holes exert the same gravitational influence as any other object of their mass. It's just that their extreme density packs that mass into an incredibly small space. Despite their fearsome reputation, black holes play a crucial role in the evolution of galaxies. They act as cosmic anchors, their gravity influencing the formation and motion of stars and gas clouds. Chapter 4. Journey to the center of the Earth, our planet's fiery heart. We often marvel at the beauty of Earth's surface, from towering mountains to vast oceans. But have you ever stopped to think about what lies beneath our feet, deep within the heart of our planet? It's a place of intense heat, pressure, and forces that have shaped the world we know. Imagine a journey to the center of the Earth, descending through layers of rock and metal, each with its own unique properties and secrets to reveal. As we delve deeper, the temperature rises dramatically, fueled by the residual heat from Earth's formation and the decay of radioactive isotopes. At the Earth's core, temperatures soar to an astounding 5,200 degrees Celsius, hotter than the surface of the sun. This intense heat is generated by the immense pressure of the overlying layers, squeezing the core like a giant pressure cooker. But the core isn't just a ball of molten rock, it's divided into two distinct layers, the outer core and the inner core. The outer core is a liquid layer of iron and nickel, swirling and churning like a cauldron of molten metal. This constant motion generates electric currents, which in turn create Earth's magnetic field, a protective shield that extends far out into space, shielding us from harmful solar radiation. Without it, life as we know it would be impossible. Deeper still lies the inner core, a solid sphere of iron and nickel, despite the extreme temperatures. The intense pressure at this depth forces the atoms to pack together so tightly that they can't exist in a liquid state. The inner core is constantly growing as the Earth cools, with molten iron from the outer core solidifying at its surface. This process releases heat, which drives the convection currents in the outer core, perpetuating the cycle that generates our planet's magnetic field. Chapter 5. The Expanding Universe, a Cosmic Perspective. For centuries, humans believed that the universe was static and unchanging, a vast canvas upon which the celestial bodies played out their roles. But in the early 20th century, a revolutionary discovery shattered this long-held view. The universe is expanding. Imagine baking a loaf of raisin bread and watching as it rises in the oven. As the dough expands, the raisins embedded within it move farther apart from each other. This is analogous to what's happening in our universe. Galaxies like those raisins are moving away from each other as the fabric of space-time itself stretches. The first evidence for this expansion came from astronomer Edwin Hubble's observations of distant galaxies. He noticed that the light from these galaxies was shifted towards the red end of the spectrum, a phenomenon known as redshift. Just as the sound of a siren gets lower pitched as it moves away from us, the Doppler effect. Light waves from receding objects are stretched, causing them to appear redder. Hubble discovered that the farther away a galaxy was, the faster it was receding from us, a relationship that became known as Hubble's law. This discovery revolutionized our understanding of the universe, implying that it had a beginning, a point in time when everything was compressed into a single point of unimaginable density and temperature, the Big Bang. But the expansion of the universe isn't just a relic of the past, it's an ongoing process that continues to shape the cosmos today. And not only is it expanding, but the rate of expansion is also accelerating, driven by a mysterious force known as dark energy. The implications of this accelerating expansion are profound. As the universe continues to expand, the galaxies will move farther and farther apart, eventually becoming so distant that their light will no longer be visible to us. The universe will become a colder, darker, and lonelier place. But don't worry, this cosmic fate is billions of years in the future. In the meantime, we have the opportunity to marvel at the wonders of the cosmos and continue to unravel the mysteries of the expanding universe. We've embarked on an incredible journey today, exploring just a fraction of the mind-blowing facts that our universe and our planet have to offer. From the age of the cosmos to the mysteries of black holes, we've only scratched the surface of what's out there. But remember, the universe is vast and full of wonders waiting to be discovered. So keep that sense of curiosity alive, keep asking questions, and never stop exploring the cosmos. And if you want to join us on this incredible journey of discovery, be sure to subscribe to FACTENOVA for more mind-blowing facts about our universe and the planet we call home. Until next time, keep looking up.